the previous numbers put together, and then this side is basically a reversed. Basically, it's the same thing as the same thing as the leftmost side, but it is in reverse. So that's the reason why we have pattern. So here pattern, we basically, we add the white space and then the other previous numbers here, any previous numbers if they exist, and then we append it, and then that basically forms the pattern. And then after that, after we have the pattern set, like this area, we now add it to the current counter, which is this area. So that's how we have 1 2 1, or 1 2 3 2 1, or 1 2 3 4 3 2 1. And after, we're gonna add it to the same pattern but in reverse. So so this is basically the slicing operator that I mentioned earlier. So here we don't have a start, we don't have a stop, but we have a step. So what step does is basically determines the how the operator will go through how it will iterate how it will iterate through through the array, or the list. When you put -1, it actually starts counting backwards. So instead of counting from 1 2 3 4 5, it starts counting from 5 4 3 2 1. And this is actually how we're able to generate. And one big crucial detail that makes it different from reversed is that reversed only iterates through it only iterates through the list without changing it. But creating a slice operator actually not only reverses this quote unquote list with this specific setup. Of course, if I put a different start or stop, it will create a whole different list. It won't just be reversed. But not only will it reverse, it will also create a new object. So now this is a completely separate object, and that's how we're able to add it here. Because I did try using reversed here, and I got oh shit. Okay, I lost the screenshot, but I basically got a error that the pattern with the reversed function is not something that you can add to it's not something you can concatenate with a string. And so that's why we use this slice operator, so that you can actually create a new object, and that object can be used in this concatenation line. And so that's how we were able to create we're able to create this triangle. And so as you can see, yeah, this is exactly what I explained. So it would basically just go through each one, and then as after it prints, it add basically the previous number. So the current counter gets added to this array previous numbers. And so it gets added to the array. And so if ever we're going to the next counter, and it's gonna start creating its pattern, it's gonna add the string it's gonna add the string number. It's gonna add the previous every single item within previous numbers into the current pattern. So that's how we get this, as I explained, that's how we get 1 1 2 1 2 3, and then we add it to the current thing, and then we reverse it. And that's basically how triangle works. So now diamond. Okay, so diamond's a little bit more interesting. So for diamond, we have something called edge. So this is why we have import math on top of the this is why we have import math on top of the code. So the reason is because we need ceiling. So what ceiling is it's a special type of division. It's called ceiling division, where any value that has a decimal, it will always round it up. So it's a direct opposite to floor division, where it will round it down. So here what we have is the total length of the range, and then we divide it by 2. The reason why we divide it by 2 is because we want to get the middle section of this diamond. The reason I'll explain that in a bit. So essentially, okay, so as you can see here, once again, white space, the number fill. So essentially, it's kind of the same idea, where number fill is basically this. We're basically iterating through, the to the counters, and then number fill is this section, and then all the white space, and then we basically reverse it right here. So as you can see, we have the same we have the same pattern added by counter, added by the reverse of that pattern. And so that's kind of the basic idea. And so we move on to this. So on the greater scale, the reason why we have the edge is that the moment, so basically what happens is that from here it basically iterates, so it basically keeps on adding, it keeps on increasing the number of of number fill, the number of white space. But the moment it reaches the edge, it should start decrementing, and so instead of adding more number fill, it should start decreasing. So that's why you can see here we have an else statement. So depending on that else statement, we have a it's kind of it's kind of the same code, but here we basically changed the we basically changed the white space and number fill. So here white space is still edge counter, it's edge minus by counter. Here it's counter minus by edge, because obviously counter would be greater than edge at this point. And then here, instead of just counter minus 1, now we have the length of the range minus by counter, because counter is now quite a big number. So one other thing as well is, depending on whether what you input is a positive or a negative, it actually changes the shape. So as you can see here, so here we only have one middle section here for the edge, but that's only for odd numbers. But especially for even numbers, instead it will add another layer so that it kind of pads it out a bit, so it's a little bit more of a fatter diamond, but it still forms the general shape of a diamond. And so that's why we have here the modulo is just to check whether the range is odd or even. And of course the and is so this and case, this else if here, it basically checks, it's basically to generate this, is because the moment you pass through the first basically the first instance of the edge, it will basically start decrementing. But in the case of even, we don't really want that to happen. We want to have this extra edge, as I would say it. So essentially we have this function here to check, okay, if it's even, and also did we just pass by edge plus 1. So that way we can basically just we can basically print this current counter, but now with the same size as the previous edge instead of decrementing. And so we simply go here. We also have the same if else here for even or odd. So that's only really there because some of the like the calculation for white space is a little different. So here it's -1, but here it's just subtracted by edge regularly. That's just because when I was testing it, when you put different numbers, it was slightly askew. There was a little bit too much white space, so I had to add that. So now finally, let's move on to the final pattern, which is the hourglass. So for hourglass, we simply present 5 5 5 5 5 4 4 4 4 3 3 3 2 2 2 1, and then after we reach that, we basically create another. We basically just kind of mirror it. So the way I kind of did this is by separating it into two parts. So first we have the first, I would like to call it the first loop, and then we have the second loop. So here we create the top. The first loop creates the top of the hourglass, while the second loop creates the bottom of the hourglass. So the way we do it is, first of all, we have to do a little bit of math. So as you can see, if we actually count the amount of fives in the, assuming 5 is the maximum number here, if we count the amount of fives in this hourglass, we get 9. And if you count the 4s, we get 7. And then we get 5, 3, and then 1. So these are not only odd numbers, but if there's actually one thing you notice, if you actually multiply 5 by 2, it will give you 10. And if you subtract it by 1, it's 9. And then you do the same thing for 4, it will be 8, minus by 1, 7, and then 3, 6, minus by 1, 5, and so on and so forth. And as you can see, it directly correlates to directly correlates to the total number of the total number of fives in the oops, don't mind that. Anyways, the total number of digits within this layer. So we basically will use that formula to, we basically use that formula to iterate through one. to we basically iterate that we iterate through the loop and create that many digits, and then we move on to the next loop. So same thing here. You have pattern. Pattern is just for the white space. You have display. So as you can see, in range of item, which is the counter times by 2 minus by 1, and so we will present that many numbers, and after that we print, and then we reset pattern. And so there's another thing called here dot reverse. Okay, so dot reverse is interesting. So while the reversed function, so the reverse function takes a list and then it simply iterates through it without changing it. The slicing operator with -1 creates an entirely new object by counting backwards, or based off the parameters you set. So, but the colon -1 will basically go backwards and create a new object, completely separate from that list. What dot reverse does is it takes that list and simply reverse it. It basically puts them in a reversed order. So the reverse is good for just simply printing if you just want to iterate through a list in the opposite direction. The slice operator is if you want to create an entirely new list, an entirely new object, and then use it in any way, shape, or form. And here the dot reverse function is good for basically taking a current list and then just changing it to be in reverse. So this time you actually have the intent of using that entire list in a reverse function instead of just iterating through it like what I was doing in the previous functions. I didn't really want to change the rain the the inputs, the content of that list. So the reason why we want to do this is because obviously, if I put number 5 and then based off the previous function, it will basically create a list from 1 to 5. So in order for us to start with 5, we simply need to reverse the list first, and then we can start performing the construction of the pattern. And then we basically did the same thing here. So we reversed it again so that we start from 1 to 5. And the reason and here, the one last thing to explain is this is an exact mirror. This is an exact mirror of the code on top, except for one detail, and that is this final slice operator. So earlier I talked about stop, I talked about step, and now let's talk about start. So here we have start. So it's the first parameter in the slice operator, and so what it does is that it specifies where a list, or where when you start iterating upon a list, where it should start. So here visually we have the list. You can say it's from 1 2 3 4 5, and since we are starting from 1, so basically the address here would be let's take a brush. It will be 0 1 2 3. Since we're starting from 1, so it basically completely ignores 0 and starts from 2 instead. So that way we can actually create this we can create this hourglass without repeating the 1 here, and so it starts from 2 and then 3 and 4 and 5. And so it's just the same logic as this but in reverse. And so that's pretty much it for the entire code. It's a very long process, but it was pretty fun. So thank you, and that's it.